Good morning, dear. Before we talked about the median, which is a segment drawn from a vertex to the midpoint of the opposite side. We talked about the height, which is issued from a vertex perpendicular to the opposite side. We talked about the bisector, which divides the angle into two equal adjacent angles. Today we will talk about the perpendicular bisector of a segment. As a definition, the perpendicular bisector is a line. It's not necessary to be issued from any vertex. It's just perpendicular to a segment at its midpoint. In other words, to simplify, the line that cuts perpendicularly the segment at its midpoint is the perpendicular bisector of this segment. And as we saw before, any point on the perpendicular bisector of a segment is equidistant. It means having the same distance from both extremities of this segment. For example, ABC is a triangle. Now, D is perpendicular to AB at its midpoint P. How did I know that P is midpoint of AB? Simply, we have the same sign on AP and PB. So AP equal to PB, then P is the midpoint of AB. And since D is perpendicular to AB at its midpoint P, then I can clearly say that D is the perpendicular bisector of segment AB. Now, ABC is a triangle. Here we have line D1, which is perpendicular to AC at its midpoint Q. So what do we call D? It's the perpendicular bisector of segment AC. Now let's draw D2, the perpendicular bisector of AB. Then D2 is perpendicular to AB at its midpoint, here M. The first step is to locate M, the midpoint of AB. Then I have to draw by using my set square the perpendicular to AB at its midpoint M. Then I can say that D2 is a perpendicular bisector of AB. Or I can use my compass and I'll show you how later. Now, D3 is perpendicular to BC at N. Then N is the midpoint of BC, and we draw the perpendicular to BC passing through N. Then D3 is perpendicular bisector of BC. The three bisectors intersect at one point. This is the point. Look well. The red line, the blue line, and the green line. The three perpendicular bisectors intersect at one point, so they are concurrent. P is the point of their intersection. So what do we call P? It's the circumcenter or a center of circle circumscribed about a triangle ABC. Circumscribed means the circle is drawn around the triangle ABC and passing through all its vertices. Look well. This circle passes through point A, point B, and also through point C. Please, you have to notice that the intersection of the bisector of the angles of the triangle is the end center. If I draw the bisector, then the circle with the center, which is the intersection of the bisector, is the circle in this case is inside the triangle, while if I draw the perpendicular bisectors, their intersection point is the center of circle circumscribed the triangle or drawn passing through all the vertices of the triangle. Now, the circumcenter may be outside or inside the triangle. In acute triangle, the circumcenter is inside. Here, for example, we have acute angles, the three acute angles. So this triangle is an acute triangle. if I draw the perpendicular bisector of the first one, the second one, and the third one, then the intersection of the perpendicular bisector is the center of circle circumscribed about the triangle, and as we notice, this O, the intersection point, is inside the triangle. Why? If the triangle is obtuse, here for example, EDF. EDF is an obtuse angle, so the triangle EDF is obtuse. If I draw the perpendicular bisector of the first, second, and third side, they don't intersect inside the triangle. If I elongate these lines, they intersect at a point completely outside the triangle. Okay, so the circumcenter, if the triangle is obtuse, is outside the triangle. In a right triangle, the circumcenter, here for example, CAB is a right angle, so the triangle CAB is right. If I draw the perpendicular bisectors of the three sides, the intersection point is the midpoint of the hypotenuse. What do you mean by hypotenuse? It's the side facing the right angle. Here, the right angle is CAB, the hypotenuse is CB. If the triangle is right, and this is a very important point, the center of circle is the midpoint of the hypotenuse. Okay, you have to memorize well this idea. Now, how to draw a perpendicular bisector? The first step is using a ruler and a set square. We measure the side using a ruler. Here, for example, BC, starting always from the 0, BC equals to 8 centimeter. What's the half of 8? It's 4. So at 4, I have to plot the midpoint. And then, this is the midpoint. By using my set square, I have to put one of the edges on BC and draw a line on the second edge so that it's perpendicular to BC at its midpoint M. Okay, now I can say that D is the perpendicular bisector of B. The second method of drawing perpendicular bisector is using a compass. We draw an arc of center A and of radius greater than the half of the side AB from both sides. Since I'm going to draw the perpendicular bisector of AB, I have to open my compass as we did before. On the first, put the needle of the compass on the first extremity, which is A, and draw an arc on both sides of AB. Then, without changing the radius of the compass, I have to put it on the other vertex, which is P, and draw arcs on both directions of AB. Now, I will join these the point of intersection of these arcs together to form the perpendicular bisector of AB. Now I can say that K is the perpendicular bisector of AB since K is perpendicular to AB at its midpoint. These two perpendicular bisectors intersect at a common point here, which is called the circumcenter. The intersection of the perpendicular bisector is the center of circle circumscribed about triangle ABC. So if I put the needle of the compass on point P and open it with the radius AP and draw this circle will pass through A, B, and C. Okay? Now, to draw the circle circumscribed about ABC, as we said, you have to put the compass on P and its other arm on one of these vertices, A, B, and C, and draw a circle that is circumscribed about the triangle ABC. Now I can say that PA equal to PB equal to PC. Why? Since P is the center of the circle and PA equal to PB equal to PC, they are radii of the same circle, and we know that radii of the same circle are equal. You have to solve these exercises and hand in your work in the assignment. Thank you for your attention.